This is section 4.9. We're going to perform congruence transformations. If you remember, a transformation is an operation that moves or changes a geometric figure in some way to produce a new figure. The new figure is called the image. A transformation can be shown using an arrow. So when you see this arrow, we're talking about triangle ABC being mapped onto triangle PQR. Notice how I use colors here so you can see which parts correspond. The order of the vertices in the transformation statement tells you that P is the image of A, Q is the image of B, and R is the image of C. There are three main types of transformations. A translation moves every point in a figure the same distance in the same direction. A reflection uses a line of reflection to create a mirror image of the original figure. And a rotation turns a figure about a fixed point called the center of rotation. So here's just a little review. This is what the reflection looks like. This is the rotation, and this is the translation. Name this transformation. This would be a reflection. Translations, reflections, and rotations are three types of congruence transformations. A congruence transformation changes the position of the figure without changing its size or shape. So here's some information about translations. In a coordinate plane, a translation moves an object a given distance right or left and up or down. You can use coordinate notation to describe a translation. So here's coordinate notation for a translation. You can describe a translation by this notation. We're going to take every single point, this order pair XY, from this blue figure and move it somehow. We're going to take all of the x's and add a to it. So this x value, we're going to move it a units to the right. That's what that means. If you're adding a, it's moving to the right. If you're adding b, you're adding a different number b to your y's. That means you're moving it up. Now, if you were subtracting here, you would move this down, or if you were subtracting here, you would move it down. So basically, here's what this means. Take all of your ordered pairs x, y, and move them a units right and then b units up. So you do that for that vertex. You do the same thing for this vertex. Move it a units right, b units up. Same thing for this guy. Move it a units right, b units up. And what you end up with is three vertices. That would be your image. So here's a good example. Here's figure ABCD. It's a four-sided figure. It has these vertices, A, B, C, and D. Sketch this figure ABCD and its image after the translation. So we already have this sketched. We already have these coordinates written down. What you need to do is figure out where this figure is moving. Notice how we're adding 5 to x. That means we're moving 5 right. And we're taking 2 away from y. That means we're going to move 2 units down. Okay, so if we do that, here's where we end up. Add 5 to your x value. Subtract 2 from your y. So this ordered pair for A turns into this guy, 1, 1. Add 5 to x. Take 2 away from y. So this segment AB is turning into this segment over here, and that kind of makes sense. This ordered pair for C, we're adding 5 to the x, and we're going to subtract 2 from the y. D, we're going to add 5 to the x, and we're going to subtract 2 from the y. Now, if you're doing this on a piece of graph paper with some geometric tools, this should look exactly like that. It doesn't really look like that here on mine because with this mouse that I'm using, it's not really super precise, but that's the idea. This figure is turning into that figure. We'll talk about reflections in the next one.